Okay, so the next question is Dakota's sprint here, and what we can see is a graph, and we've got questions around displacement, velocity, and acceleration. So the graph is of Dakota's velocity over time, and question A is asking what was Dakota's displacement between 2 and 5 second marks. Now, immediately a lot of people's mind when they get a question about displacement are kind of expecting displacement in the graph, but that's not the case here. So just remember that this graph is around velocity, but as we know from kinematic concepts that if we have data around velocity over time, then we can use that data to calculate and understand things about displacement as well as accelerations, and that's what these questions are about here. So what's Dakota's displacement between the 2 and 5 second mark? There's a few different ways to do this actually, but I find the simplest way is to break down each second. So we've got 3 second periods. If we break down each second, then your velocity over a second, your average velocity over a second, is the same as your displacement. So think about it, if you're traveling for 5 meters a second for 1 second, you would have traveled for 5 meters. So we're just going to use that across these 3 seconds here. So if we go between the 2 and 5 second mark, then it's pretty clear that Dakota is traveling on average 3 meters a second for that whole second. So that Dakota would have traveled 3 meters during that time. So displacement between 2 and 3 second mark is 3 meters. Now if we take the next second between the 3 and 4 second mark, Dakota starts at 3 meters a second and finishes at 5 meters a second. So the average velocity during that period was not 3 or 5, but 4. So then we've got 4 meters in the second there. Now that last second, Dakota starts at 5 meters a second and finishes at 6 meters a second. So the average velocity was 5.5 meters a second, and therefore the displacement was 5.5 meters during that period of time. So if we add 3 and 4 and 5.5, the displacement over that 3 second period was 12.5 meters. So pretty easy calculation, hopefully. It's just a conceptual one that some people find a little bit tricky. Okay, what was Dakota's instantaneous velocity at the 4.5 second mark? Again, people probably overthink this quite a bit, and you can do it again in a few different calculations for this one. But this graph is showing velocity, and instantaneous velocity is just the velocity at that point in time, calculated by the averages around before and after, and that's actually already on this graph. So if we look at the 4.5 second mark, if we go up between the 4 and 5 second mark, so Dakota's at 5 meters a second here, 6 meters a second here, and so at 4.5 meters a second, it would be 5.5. In fact, we've already done that for the question before. So 5.5 meters per second. I've got a little calculation here if you want to look at instantaneous velocity, but you can just really read it off the graph. What was Dakota's average acceleration between the 1 and the 4 second mark? So acceleration is change in velocity divided by change in time. Now we have velocities on this graph and we have time, so we simply input those into our calculation. So the change in velocity between the 1 and 4 second mark is the difference between 5 and 2, and the change in time is the difference between 4 and 1, and so the acceleration is just 1 meter per second.